The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to our sales webinar on how to fit a Milton package into customers' needs, which will be held by Daniel Jurica. In SolidCAM 2017 and 2018 versions, we put a lot of effort to add new features that can support advanced Milton machines, including Swiss type. We did it because we believe this Milton market holds a great potential in it and gives SolidCAM the advantage we need over our competitors. Also, we want you to feel confident approaching these potential customers as you have the best product and support from our side. If you have any questions, please write them down at the question bar, and Daniel will attend to them at the end of the webinar. Enjoy. Daniel, you can go ahead.
All right. Hello, everybody. Thank you for joining us. Like Natalie said already, today we'll try to answer on the question of how to fit a Milton package to the customer needs. And I think it's very important to start the presentation with the, just a moment. I think, Natalie, can you make me a presenter?
Sure, there you go. Sorry.
All right, no problem.
Okay, yes.
All right, so I hope that everybody could see my screen now.
Yes, perfect.
All right, so before we answer to this question, I think it's very important to mention the main and the basic stuff here. So everybody, even the ones who never have opportunity to work with with the Milton machines, who never see them, or you never sell any package of these, I think it's very important to mention the very basic stuff first. These things will help us then later to answer on the question how to make correct package. Now, every Milton machine consists of two elements, or I will call it in this case devices. It is a turret and the table. The turret holds the tool and the table holds the part itself. Now, relative movement between those two devices, you can perform the cutting on the machine. Now, I'll start with the table things, and the very common device is a chuck with a jaw system. Yes, as you can see on the right side, I just put a picture here. This is a very great model that we have on. It's basically the 3-jaw system. I will also, by explaining all those elements, I will try to give you a rough opinion where they are used and what is the advantage and disadvantage in some applications. On most of the Milton machines, you will be able to see this system, yes, but it is very nice. It's for various types of the material, mostly hard one. It can perform quite good spins and RPMs, yes. But the downside of also, yeah, that great advantage over this one is those jaws can perform, a different range of the dimensions of the stock. Now, the downside is that not too big high RPMs can be done with this table because of the forces that will be applied on the very high RPMs. The better device than this, I would say, of course, this depends on the application itself, is the collet type of the table. It has, in comparing to the previous, to the 3-jaw system, he have constant area where the stock is clamped that will allow us to get much better precision on the machine, and also with very high RPMs. All right, so this is, I would say 90% of the Milton machine has those kind of tables, okay? Now I'll go to the turrets. You probably see this is a revolver, very nice. His great advantage is that tool change is very fast. the downside is that you can only attach a limited number of the tools. It's very, very, very popular on the military machines. Also, let me just go back for a moment. The downside of it that if the revolver has a capability to have a live tool, it will not be able to achieve very high RPMs with those. Yes. Now, another type of the turret is the spindles, milling spindles. They can also have the turning tools as well. They can perform very high RPMs. So I'm talking about 10,000 and up. Yes. The downside of it is that they mostly the tool change is pretty big. I'm talking about in seconds. Yes, it's not like on the turrets. They usually come with a B-axis, and they can perform very nice tilting of the tool and mill and turn in different angles. And the last turret that we can support is the linear turrets. They have pretty much similar the properties as the revolver one, but they are just positioned in linear way. Yes, they are mostly used on the Swiss type machines. All right, now once you know those things, combinations of turrets and the table, we can get many different configurations. Yes, and based on these configurations, I'll try to tell you how to actually make a optimal package for your military machine. So what is the best approach? The best approach is at a particular customer, in particular workshop, you will take the most complex mill turn machine that he has, and you will try to analyze his kinematic, okay? So I will start on the left side. I will display the most frequent kinematic that you can find on the mill turn machines. And on the right side, I will talk about the packages that you should apply to this particular customer. All right, so the first example is when we have a turning spindle over here and the rotary turret. Here I just put like 2 turning tools in this case, and here I just put the 2 axes. So relatively movement of those 2 and rotating the part, we can perform the turning. And for this kind of machines, the turning model is enough. All right. The next is very, very frequent on the market is the turret also has an option to accept the holders that can which can have also the live tools, which means you can attach the milling tool, drilling tool that can rotate. And usually those machines, of course, they come with a C-axis on their spindle. It is very known that it has also the Y-axis, but this is also this is still optional. So what we are talking now here, we're talking about 4 axes in this case, and in this case it's 2.5D milling. It's a must. While depending of each part application of the particular customer is doing on this military machine, also the iMachining 2D can be applied, HSS, HSR, and simultaneously 4 axes. All right. Now what I have here displayed is I will show you is when the rotary turret is replaced or not replaced, but when we have the configuration with spindle which has the B-axis. Now there are Milton machines that have the B-axis which is inaxial and not simultaneously. For those kind of machines, you can achieve any angle, and this configuration will be enough. But if the B-axis is also simultaneously, then I will definitely replace the 4 axes simultaneously with 5 axes simultaneously. And together with that, machine simulation, it's not anymore an option, it is a must. It is very dangerous to run 5 axes simultaneously, motions on the machine without machine simulation. The collision check must be performed on these kind of machines. All right, to this configuration, I'll just add here, the back spindle. Nothing has been changed from the packages point of view. And another proof that here is also machine simulation is necessary one of the reasons could be that also the part can start machining on the back side. As well, the part transfer can be done in different variations. Yes, so it is very important to have machine simulation in this case. All right. Very recently, since 2018, we start to support the revolvers that is on the B-axis. We cannot imagine this doing it without machine simulation. Getting the correct angle with this machine, getting correct collision control with machine simulation is a must. Okay. And on this configuration, I have added here additional turret. In this case, it's a rotary turret. It has additional 3 or usually 2 axes. And once you have the 2 turrets, 2 spindles, we are now talking about something that we call multi-channel machines. So what the multi-channel means, or what the channel means in general, each of those turrets, as you can see, we have here the upper turret, we have the lower turret, can have only 1 active tool per turret. So if we consider this turret, it can have only 1 active tool, and lower turret can have another active tool. Those tools can perform movements by the axis. And as you can see, one tool can have 1 toolpath, another tool can perform another toolpath. That's why this machine has 2 channels. For controlling of those channels and G-code output, multi-turret synchronization module is necessary. Now, if we have the 2 channels or 3 channels, the package should not be changed. The multi-turret synchronization can support unlimited number of the channels. And in this case, I just add here as an example, 3rd channel, which in this case, we can have 3 active tools which are performing 3 different toolpaths. All right. Together with that, I will back a little bit to the 2017 and also 16 in that time, when we started to support very complex mill-turn machines. And in front of you, you can see the QuickTech TH Hybrid, which I'll consider it back in that time one of the most complex machines that we've done. And it consists also the rotary turret, as you can see here. It has also the linear turret here, and also the linear another with a B-axis. But still, this machine, it's 2 channels. As you can see here, the tool has one rotary turret, we can have only 1 active tool. On another, we can have another active tool, which means that this machine is only 2 channels. Now, in this time, we started to very frequently get the request for the Swiss type. So it came from the customers. It's like, can we do it for this particular model? Back in that time, we didn't actually have a knowledge or information what are the customer issues, what is the kinematic of these machines, how the G-code looks, what is the kinematic. So all those things back in that time we was not 100% sure can we support it. Today, I can say freely we can support advanced mill-turn kinematics, including the Swiss type. And in the following slides, I will try to explain you what are the main differences between the regular, or I will call it also conventional mill-turn machine with the Swiss type, how to make a proper demo, what is the minimum information that you need to know regarding to the post-processors, and how to correctly configure the Swiss type package. All right, so a few slides here. It's just what we've done since 2016 and 2018, start working on the beta projects in order to bring the solution to the highest possible level that we have today. And I will just start with very basic stuff and a little bit of the history. And they're commonly known as precision automatic lathes, Swiss type lathes, and all these Swiss screw machines. Also recently, I found out on the website they're calling it also long turning lathes. But basically in SolidCAM, we call them Swiss type. All right. The they are not made in Switzerland, but back in 1960s, they were made for the Switzerland watch industry. Yes, and the concept of the Swiss type machines was made, for this actually application. And today it's not only in watch industry, but also in automobile, electronics, aerospace, very, very, very big jump in medical industry, a lot, I will say. All right. Now, I for many time I was trying to find a proper word of what Swiss type machines are, and I put it in one actually. One thing I'll just say that Swiss type machines actually provide a cost-effective way to produce very small parts that are complex and very precise in very large quantities. I will always jump on this sentence. It's very important. In the following, I will try to bring you this thing as much as possible. Yes. Regarding to the materials, I think there's no limit regarding to material. There is like non-ferrous metals to stainless steel, plastic, nylon, titanium. There is all these machines can do it. Yes. But the main advantage, what brings them up in a big advantage in comparing to the conventional mill-turn machines, is the dimensions that they can do. We are talking only up to 36 millimeters in diameter, and what is most important is the length and diameter ratio of the parts can be bigger than 5. All right. Here I just put some of the pictures of the parts that can be machined. And when I say cost-effective way, I will just show you this slide over here. I just put all the machines known to the market that it's on the behind is the Mazaks and DMG, and sorry, Mori, and in the front one I just put few Swiss type machines. So even if you can make the same precision on the following part, even if you can make the same cycle time, the Swiss type machines are less, their consumption less energy. Yes, so we are talking about you will never be able to compete against these small machines in those kind of parts. All right. Now, what is the main thing? The concept is different. What you can see in this case is the standard mill-turn machine. So this is something that I already showed you. You have the chuck, you have the spindle chuck, and you have the bar that it's clamped, and the tool is making the main movement. Yes. Well, for the very long parts that are also small in diameter, you will have deflection and vibration over here. Of course, you can use the tail stalks and those and additional support devices, but for very small parts, it will never be cost effective. Now, if we analyze the Swiss type, I will just spend a few seconds on this. We have a little bit different, but the results are dramatically different. We have here the chucking collet over here that actually holds the bar and moving the bar along the z-axis, while the guide bush is stationary, just rotates in the same speed as the bar itself. But the purpose of the guide bush is the purpose of it is to offer additional support to the stock material. And in that case, the tool is just moving relatively and the machining is performed, which will have the minimized deflection and vibration on the part. So this is the main difference. All right. In this slide, I just spent some time in analyzing the market, and in the past, I don't know, 2 or 3 weeks, there was the AMB there in Germany, and analyzing the market, I put from the top to the bottom the most expensive and most popular machines, and at the bottom, and I will also say the most precise machines. And as going to the bottom, you will get less precise and less expensive machines. Definitely, the Tornos, DMG, Mori, and Index, they are on the top, which they're also very much located into a medical industry. Yeah, and very popular is the Star Citizen, also Tsugami, Nexturn machines, yes, as a mid-range Swiss type machines. Now, what I will here mention is that this is not same in all countries, yes, but my advice to all of you in your countries, if you have specific Swiss type manufacturer, try to get in touch with them. Try to make a partnership. Try to make any contact. It will be very valuable for getting the information, for getting the manuals, for good cooperation, and for the marketing. Okay, why we are choosing Swiss type directions? I already mentioned that it is high market potential. Yes, we started with a lot of requests. Yes, and we start to analyze it. We get to it that it's very important market. Besides of that, making the software in this direction, it will not give us only advanced solution in Swiss type, but also it will improve our existing Milton solution. Besides of that, our customer need the Swiss type. Our already customers, yes, of the Milton machines, they start to ask us, okay, can you make also the Swiss type? I would really like to have the only one application that I'm machining, that I'm making the part, programming the parts in one system. Yes. So this was very important to us to make our customers satisfied. And also, it is not a secret to say that only they're very rare, not that a big amount of the CAM system that can support those machines. They are very complex. They are very hard to maintain it. They're very complex in kinematic. So just I lost the sentence, but that I guess that you get the point. Now, regarding to the Swiss type customer difficulties, I will just mention here a few of the points. Most of the Swiss type customers, they are making the parts just writing manually the G code, which actually the problem with that is that there's also no visual verifications, yes, and the operators hold the knowledge. The customer is under the pressure all the time. If anything happened to his operator, his machine will basically stop. And also today, I think in the past, I would say 4 or 5 years, we see big jump into the Swiss type area. Machines start to be very complex, and they also start to put a lot of tools, a lot of linear tools. They also start to add the B-axis inside. On the beginning, it was only positioning, but today we can see there are also many simultaneously B-axis. Also, last exhibition, we saw that there is not only one B-axis, but there are more B-axis. So making the parts in these machines by doing it manually on the controller itself, it's a mission impossible. The customer needs a CAM solution. All right, now who are our customers? I will divide this into a part geometry. On the left side, I just put the parts that are fairly easy to program it even manually. And those customers who are producing these kind of parts only, these are not our customers. Our customers are the customers who actually program complex parts, yes, so which are very hard to programming by the hand. From point of view of machine-related things, I would say that if the particular customer have more machine in his workshop, the harder is to get all the knowledge inside of operator. Yes, so you need to put everything into the system. Would be much easier into a CAM solution. Yeah. So the customers who actually have different machine models, not only one. This is very common case. If the particular Milton machine, Swiss type machine, has 5 or more controlled axes, this is very nice case. And here I just put one small video of 5-axis positioning and simultaneously machining. I will say those kind of things, I will say it's completely impossible to program it manually. And a few things before I go to the next presentation regarding to who are our customers. I would say that giving a Swiss type solution to customers should be done with some priorities. I think my opinion is that we should start with customers already, our customer who already have the Milton solution, yes, to satisfy first our already existing customers. The second priority would be definitely for the customers who have a need for the Milton, but they also have a Swiss type and they're brand new customers, yes. And the third, I will say the last priority that you should be focused on are the customers who have only Swiss type machines. Yes, so I will definitely say that those customers have a lot of machines. They are also good customer, but definitely with a less priority in comparing to the first two mentioned. All right, now something regarding to the machine kinematic. Now, while I'm explaining all of those things in the few next slides, this will help us to exactly understand what are the main differences of how to make correct package, okay, and what are the minimum information that you need to bring to us with the question of, okay, how do we have this post in our database, okay, or if we do not have, those informations will be very useful for the post-processor building. Yes. So first of all, I have here very standard Swiss type machine. This one is Citizen, but it doesn't matter that many machine brands have very similar kinematics, as you can see on this following picture. This machine has 7 axes, programming axes. And as you can see here, it consists of many linear tools here, very different linear turrets. We have also one over here for the back spindle. Also here, I just put one very unreachable angle. It's from this side. It has another turret that can also have milling tools. Yeah. So the axis layout is very important for this thing. Yes. Now here I just put how those turrets are called and all those kind of stuff. This thing at the moment is not important. They all have, of course, the name, but this is something that is important in the next few slides. I've have a few questions regarding to Citizen. We start to get very frequently the questions: can we support these machines? Do we have available post here? Yes. And then when I ask, you know, what particular machine it is, this is just particular example, but it's coming like this. So it's Citizen Syncom L32. Do we have the post for this? It's a little bit different than the standard Milton machines, because these machines can come in many axis configurations. Usually it's not a lot of different, but basically this L32 means that 32 mm in diameter can be machined, yes. But M8 here in this case represent the axis configuration. And the machine that I show you here with this axis configuration is the M8, yes. But some customers say, okay, can I have the B axis on this machine? Yes, but this is completely different configuration, and in that case, it would be used M9 or even M12. So the machine configuration as the axis configuration is very, very important to know what is at what customer actually has. Yeah. How to get that? I think you can also take a picture from the plate on each machine model. This also represents what is real machine configuration. And the second thing, what is the difference in comparing to conventional Milton machine, is the holder configurations. Now, what is all about? Here, as you can see, here I take the example of the star machines. As you can see, it is pretty similar what you see just a few slides before. Just the main spindle here is on the left side over here, and back spindle is on the right side. But all those things, what I have put it's not visible, of course, on the machine. I just put it here in machine simulation, so it's much understandable for us when we are using it in simulation. Yes, but all those things are the holders or devices that you can attach the holder, and each of those models it can vary on each machine. So I will give you one example. Here we have something that is called in Swiss type the gang tool gang post, yes. And in this particular case, you can here attach 6 different turning tools. Now the customer can say always, I would not like to buy the machine with 6-1, but I would like with 5 or even 7. So this is an option on the Swiss type machines. Also, different holders. It means directly different holder configuration. So generally, for all of you, you need to understand that holder configuration. You need always to ask the customer, okay, what are the all holders that this particular machine can use? So this is very important later on for the post-processor development. All right, now once we know all these informations, I hope it was not too much, I will talk about how to correctly configure the Swiss type package for these machines. Yes. So the minimum package for each Swiss type is 2D turning, 2.5D milling, machine simulation, multi-turret synchronization, and the Swiss type module. I'll first start something regarding to the multi-turret synchronization, why we do need it. Of course, there's no Swiss type that is single channel. I mean, analyzing the market, I figured out that all of them are at least 2 channels. Yes. So, but what is the delta to it? All Swiss type customers always produce, in parallel, as you can see here in this picture. Advanced channel synchronization is a must. Yes. Something about machine simulation. Maybe some of you will ask, okay, why we do need machine simulation for even if it's very simple. If it's a very simple Swiss type, I would say, okay, maybe not for every case, but if we take a look on this machine over here, it has many tools. Yes, making a good collision checking together with good tool setup and everything, it would be the best with the machine simulation. It will directly also affect how the G code will be also generated correctly or not. Yes, so it's much better to see everything more visualized. Yes. To not mention the machine simulation for this particular machine, it's a must, because I would connect, this to the previous or the second slide that I have shown you. This particular machine also have here, you can see the B-axis. If it's not in general, it's not simultaneously if you don't buy an option. Yes. So together with that, and according to what customer bought as an option, or according to the application that a customer can machine, you can also attach here or add HSS, HSR, and simultaneously 4-axis. Or if the B-axis is also simultaneously, we can also offer the simultaneously 5-axis model. And now the very frequent question is coming recently, that should we offer the iMachining 2D? I will tell you few things regarding to the Swiss type. As I already mentioned, it's up to 36 mm in the diameter. So there are also very small parts. To machine those things, you usually need a very small tools. Those holders that you can see over here, they offer very, I will not say low RPMs, but something like 6,000 is a maximum, yes, that you can achieve for a very, and not for a long time, it's for the short time. iMachining 2D, in that case, we have already a few customers who is using iMachining 2D. And they're very satisfied on the Swiss type, yes, but I would mention that this is not a rare case that customer would need it for their applications, yes. And what I here show you, it's only if the particular customer have the Swiss type package, yes. But if the customer already have previously the Milton solution, definitely iMachining will be an awesome solution. All right. Now, also the frequently asked question was for us was what is the Swiss type module? Swiss type module is a must for every Swiss type machine. Okay. As you can see on the picture on the left, we have many turrets over here, many of them. They're all controlled by the single channel. Let me explain it a little bit better. We are allowing to have multiple turret, more turrets than the channels in this case. Yes, together with superimposition features, inversing Z, left-hand quarter system, and etc. Together with more than one axis pattern. Okay. Maybe it's from technically point of view very difficult, or sales point of view very difficult, but just in general, all Swiss type machines must have Swiss type module. All right, and as the last slide on this presentation, I would just like to mention few key features for that you can mention in every demonstration of the Swiss type. But I will also mention this, that it's not only for the Swiss type, I think it's for the Milton in general. First of all, we can support advanced kinematic. We show you here a lot of different kinematics, very, very difficult one, very complex, yes, so we can support them both. Regarding to the Swiss type, there is something that I didn't say, but it's nice to that you can show it. It's that we can support the guide bush. This is something that I talk about it, but also we can support the guide bushless. This is something that is more technical. Then we have machine preview. I would say that machine preview is something, one of my favorite features that I always use in Milton. It allows me to see the current status of the machine in any moment, in any operation. Very nice in tool table and etc. Yes. I also mentioned here the support of holder configuration and channel synchronization together with adding a new workpiece. As I mentioned, there's no customer of the Swiss type that will not use add a new workpiece. All of them will always use add a new workpiece function. Of course, the superimposition, axis patterns, and drive and axis sharing. We were always easy to use and always fast program creation. This is a key point of the Swiss type. If the customer is using very simple parts, he can program it very fast, also manually. Yes, but for the complex parts, we always need to provide a solution that is very fast program creation. But that way we can compete against the operator. We can easily generate the G code for any particular machine, and we can also make a visual provouts. This is something that Swiss type operators have only in their dreams. So they would like to see their movements, they would like to see the machines, they would like to see the tool change and so on. Yes. So I would say also when the two channels work in parallel, I hear mentioned like 2 or more stocks machining. It's very nice to simulate it before you actually go to the machine. And also I hear mentioned that the viewports, today it's very important to simulate in from 2 different angles. Yes, so today we can provide you this solution. And the last thing that I think is the very, very nice to mention is that we should never forget that we are programming in SolidWorks and in the inventor environment. Yes. And we have association with a CAD model. I think this is a very important, very, very important point. And today I can say freely now that we are the only CAM system that support the Swiss type within the SolidWorks. Yes. So if the customer have already something, they are using the SolidWorks as their CAD, and if they have the Swiss type in their workshop, there's no other CAM that today can provide solution except of SolidCAM. And for the last here, I just put one hyperlink, so everybody of you will get this presentation, and you will be able to get you'll be able to click on this, and this is just our personal database collected from the support channel. That it's not only for the Swiss type. I'll just jump there. And what I have here is is the folders between inventory, of course, and SolidCAM. We have here different applications, yes, not only for the mill turn, but also for the 5-axis. You can find here everything. And what is very important that we are always updating it, yes. So you can very, very nicely jump to, for example, I here go to the switch type. I will go to a particular folder, and besides of the project itself, you'll be able to see the picture before you actually download this project. All right, I finish with my presentation. I hope that you all enjoy. I have no doubts that you have a question, but the question is, do you have it at the moment? Natalie?
Okay, this is Sydney actually speaking now. Okay, there are some questions over here, and I'll just read them off to you. Okay, first of all, one question was if the reason why you haven't listed HSM in your list of.
All right. All right. So let me say why not HSM. The HSM is I'm considering personally the module that is it's of course nice to have, but if you have only the mill turn, yes, and the based on okay. So what I said in the presentation is I make the packages according to the machine needs. So if you give these packages for the to the customer, he will be satisfied and he will be able to use complete all functionality of particular machine. Yes, but based on the application of the part, HSM can be also module inside. But from my experience, most of the customers were quite satisfied with HSS and HSR.
Okay, there's one more question. I think you did touch on this in the presentation. Just want to maybe re-mention it. You were asked to please tell about competitive advantages of SolidCAM with other advanced CAM, for example, Esprit, HyperCAM, etc., etc.
Could you just repeat the question?
Sure, no problem. There was a request that you tell a competitive advantage of SolidCAM with other advanced CAM products, such as Esprit, HyperCAM, and so on.
Okay, I will not say, you know, and comparing against the others at this webinar for sure, but I would say the greatest advantage in comparing to others is that we are integrated into SolidWorks. I think this is the greatest advantage. Yes. Besides of that, we can support advanced Machine Kinematics. We can also simulate the things also, but definitely I would mention those things. What I said at the end, yes, advanced channel synchronization. So those are the things where we are good at the moment, yes. But I don't know how to answer correctly on this question in not going into very much depth.
Okay, no, that's perfectly fine. Okay, one other question that was asked now is, can we support also 5-axis simultaneous on 2 channels, synchronized?
That's a good question. We didn't have this kind of example. We didn't have this kind of example. So far, what I've done is just doing it on single channel. But I can check that, and I can provide the answer to this whoever answered it at the moment.
Okay.
I will check it.
Okay, you'll get the list of questions also, so you'll know exactly who to answer as well. And
all right.
Okay, there's another question probably you may be able to answer is which of the Swiss type machines do we already have working posts for?
All right. This is something that I think it would be better to create a list and then provide to send the email to everybody.
Okay, very good. Okay, the rest of the questions, you'll get the list of the questions. You can answer each one individually. Thank you again for this phenomenal webinar. Very informative. Whether you're in sales or in technical, I think there was a lot of information brought over here, and very well presented. Thank you very much. And I'd like to thank again everyone for joining the webinar, and we'll see you again in our next webinar. Take care, everyone, and have a fantastic weekend.
Have a great day too. Bye-bye.
Bye-bye.